Hey everyone, in today's lesson we'll be continuing our understanding of finding an unknown angle using trigonometry. So in question 6, a stretch of freeway rises 55 meters for every 300 meters traveled along the road. Find the angle at which the road is inclined to the horizontal. So this is our freeway, okay? The hypotenuse being that freeway where cars can go up like that. Now, it rises 55 meters here. Okay, for every 300 meters traveled along the road, which is basically this. Okay, and the road is inclined to horizontal, meaning it's at an angle like that. So find the angle at which the road is inclined to horizontal. Okay, let's find out what theta is. So opposite our angle theta is O there, H is here. So using Sokotoa, we know to use the sine ratio. So sine theta equals to 55 over 300. And then you must get rid of that sine ratio on the left side and bring that over, but change that to inverse sine of 55 over 300. And that will give us 10 degrees, 33 minutes, 50.32 seconds. But let's just say we rounded this to the nearest minute. So if we round this to the nearest minute, because this number here is above 30 or 30 or above, this number here has to go up by 1. So that has to be 10 degrees and 34 minutes. Now, let's move on. Question 7. A ladder 20 meters long is placed against the building. If the ladder reaches 60 meters up the building, find the angle of inclination of the ladder to the building. So here's the building. Okay. Draw it as accurate as possible. There we go. So there's your building. That's the box shape there. And the ladder is 20 meters long. So it's leaning against it. It's 20 meters long. And the ladder reaches 16 meters up the building, which means this is 16 meters. So find the angle of inclination of the ladder to the building. This refers to the angle that a person would have to look up to the top of that ladder, basically. Okay? Or what angle the ladder is to the horizontal that's leaning against the wall. Think of it that way as well. So, if we want to find out theta, well, this is our hypotenuse, this is our opposite side. So using Sokotoa, we know that we have to use sine ratio. Sine theta is 16 over 20. So if we write now theta equals to inverse sine of 16 over 20, we get theta equal to 53 degrees, 7 minutes, 48.37 seconds. And if we round this to the nearest minute, once again, that number here is 30 or above, so we round this number up by 1. So it's 53 degrees and 8 minutes. Question 8. An aircraft is descending in a straight line to an airport. Okay, descending means it's going down. At a height of 1,270 meters, it is horizontally 1,500 meters from the airport. Find its angle of descent to the horizontal. Select the correct answer A, B, C, or D. So, yet again, what I'll do is I draw a right angle triangle. Okay, so here's the airport, right? Where this is the floor, where this plane, or aircraft, right here, it's going to go down this way, land here, and then basically travel to the airport. So, it is 1,500 meters from the airport. Okay, so if it says 1,500 meters from the airport, it means it's directly that number of meters from the airport. So we're going to write 1,500 meters right here. Now the height is 1,270 meters above the ground, apparently. And you must write a 90-degree angle there to indicate it's a right angle triangle. We're trying to find its angle of descent, okay, to the horizontal, which means it's this angle here to the horizontal. So let's call that theta. So opposite theta here is our opposite edge, and the hypotenuse here is h. Now sine of theta would be equal to 1,270 over 1,500. Inverse sine of this, which is written this way, would be equal to 57 degrees, 51 minutes, and 3.41 seconds. Okay, don't forget to type in that degrees, minutes, seconds button to get that. Then we round that to our nearest minute, which should be 51 minutes, because that's under 30. Question 9. A tree that is 8.5 meters high casts a shadow that is 3 meters long. What is the angle of the sun from the ground? Okay. So I'll draw my right angle triangle first, and then what I'll do is I'll draw a tree, so you can see it. So here's your tree. Like that. And there's a sun here that's shining on that tree. And obviously the light rays don't go through that tree, so it's going to cast a shadow right here. So here's our shadow. But that shadow here is 3 meters long. Whereas the tree here is 8.5 meters long. Okay? So what is the angle of the sun from the ground? So here's the ground. So if the person is looking up towards that sun, the angle here would be the one to the ground and to the sun. So I've got my opposite edge, which is O, and my adjacent edge, which is 3. Right? So that means in this case, we're using the tan ratio, which includes O and A, right there. So tan of theta will be the opposite edge, which is 8.5 over 3. Let's write theta, then bring the tan over, so that becomes inverse tan of 8.5 over 3. And if I press our degrees, minutes, seconds button, we would get exactly 70 degrees, 33 minutes, and 35.87 seconds. This would round to 70 degrees and 34 minutes, since that number here as seconds is 30 or above. Question 12. In triangle XYW, angle X is 90 degrees, XY is 8, XW is 10. Find angle W correct in nearest degree. So we firstly have a right angle triangle that we've got to draw, because it says here angle X is 90 degrees. So we'll make that 90 degrees, and we'll call that X. XY is 8. Okay, so let's make this XY. And this will be 8 centimeters. Whereas XW, over here, I'll label that W, that will be 10 centimeters. So find angle W, which is this angle there. So that means the angle at the corner W. And you got to find that correct in nearest degree. So the opposite edge in this case is 8, whereas the adjacent edge, just right beside this angle and that 90 degrees angle, is the adjacent edge. So now, using our mnemonic SOHCAHTOA, we know we've got to use tan ratio. So tan of the angle, in this case, the angle here, what we use is W to denote that. Tan W is going to equal to 8 over 10. So W would equal to inverse tan of 8 over 10, if we inverse tan both sides. So if I press inverse tan on our calculators, and 8 over 10, we will get 38 degrees, 39 minutes, 35.31 seconds, and approximately what that gives you is 38 degrees and 40 minutes, because this number here is 30 or above.